Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on how to link JNI code against a C++ library. And then in the previous lecture, I showed you how to link against a scientific library and call a scientific function, like the array function. But then I mentioned it's always much better to send in primitives or array of primitives instead of sending a boxed value like a double as a class, as an object, double wrapper, right? But then we can also look at these as well. So if I go here and let's have our BI again, but this time the AI is I'm passing or sending a double wrapper, right? This is a wrapper class or a boxed value because it's boxing a primitive. Okay, so again the steps are we select our Java class. Let's go to the C++ perspective and then run the Java H tool to update the header file. And now the header file is updated, and as you can see now the BI has a J double as the parameter, but AI now has a J object because double is an object. It's a wrapper, and when we are using it in Java, it does the automatic boxing and unboxing, and we don't really notice that. But when we send it to C++, we actually send an object, right? A J object. So let's copy and paste this to our CPP file, which was array-func. And now let's comment this out, and then let's add this one. So the first pointer is JVM obviously, and then J class is the reference to the calling class array function, and now the J objects is the X, but X is now double object. So we have to, in step 1, we have to get the primitive value, get the double value of X first. And because this is an object, we have to somehow call a method on this object to get the value. So let's go back to Java here. So I'm going to quickly create a test2, public static void test2 here, and show you how to get the double value. So test2. So let's say I have a box primitive, double X is minus 1.1. all right. So if I do a sysout on this, it's fine because the Java just invokes the toString on this object. Remember, X is an object, all right? But how do I get the primitive double Y equals X, and then I use Y? What happens here? So this is an object, this is a primitive. So this was an auto boxing. We assigned a primitive to an object of type double, which is a wrapper for primitive. So the compiler Java automatically did the auto boxing for us, and here this is auto unboxing. So we are assigning a wrapper of a primitive to a primitive, and Java automatically takes the value and assigns it to this primitive. So if I run this, it still works fine. Yes. But then the question is, if I send this object double to Java, to C++, which is a J object, how do I actually get the primitive? In order to understand how to do that, we have to see what happens actually behind the scenes. So if I go to the Java perspective, to the bytecode, and click on this line, and let's zoom in to see what happens. So this is line 18, line number 18, and then it invokes virtual, which means it's invoking a method on the X object. What is the method? Java lang double value, and it takes no parameter and returns a double primitive. So basically what happens here, that actually the compiler replaces this line of code with X dot double value, and this is an instance method, right? So this is what happens. And you see the bytecode didn't change when we commented this one and added this one. So if I go back again, the bytecode doesn't change. The only thing that changes is this line number. So if I comment this and go here and save it, the only thing that changes, this line number goes from 18 to 19. The bytecode is exactly the same. So that's what we need to do. We actually need to invoke a method. So basically we need to invoke the method double value on the X object. And I highly and strongly recommend that never send a box primitive to C++, just try to send the primitive types. It's much easier, and you don't have the overhead of trying to get the value out of this object first and then do the processing that you want to do. But here, just for the sake of like completeness, I'm going to show you how to do it. So we have a reference J object. So again, what we need to invoke a method on the double class in Java. So we have to first get a reference to the J class, to the meta information. So basically, let's call this double class, and we ask JVM. We can say get object class, because we have a reference of that object here, right? Get object class, and I pass X. And alternatively, you can also use find class and give it the basically Java /lang/double. You can also do that. That's fine. So we get a hold of the meta information, and then I have to call a method. So I should get the method identifier, which is a double value ID, is JVM. And remember, it's an instance method, so you don't need to, it's not a static method. So you just invoke the get method ID, and we pass in the reference of J class double class. The name is double value, and the signature, you already know what the signature is. It doesn't take any parameter and returns a double, right? Now that I get that, I have to basically call it. So JVM, please call this method. And it's a primitive. The return type is primitive, so I use one of the primitive function calls, call double method. And we pass a J object reference, because this is not a static, so we have to pass a reference of J object, which is X, and then J method ID double value method. And this returns a J double, which directly maps to double, so J double X value. So we went through all this trouble to actually get the primitive value, the value that this double object holds. And then now we just return GSL special array AI, and we send this X value, and the mode is GSL precision double. All right. So this is how we do it. And again, if we want to call this function many times, we definitely want to cache these class IDs, or J class and J method ID. Note that we do not cache this J double, because for different double objects, this value is different. So do not use a static on this J double. All right. Because if I create different double values and send them, the J class and J method ID is always the same, but the actual value of that double boxed value, that object double, is different for different values, right? So we don't use, if you put this static, you always, and you call this function many times, this X value is only assigned once, because this is an initialization, not assignment. And that the X value is always remains the same, and that's the first value it gets when we first time calling this function. So we definitely don't want to have this as a static. All right, so let's go to C++ perspective, compile this. It both compiles and links, and we can check that it links fine. So it's linking against the -L, which is library GSL. So the linking is also fine. And we can copy and paste our dynamic library to the Java project. All right. And then we go back here, and now I can do a sysout here, array function dot AI. Remember, now AI gets a box primitive double, which X here is an object. And I can basically run this, and this should work fine. And yes, so we are printing Y, and then we are printing the X. So what happens? X is an object, is a box primitive, right? So I cannot send Y right now, because basically I guess the Java allows me to do that, because it automatically does the boxing and unboxing for me. So if I send a primitive, and if I send a primitive, Java automatically converts it to the double first object and sends the object. And then I have to go through all these hoops to get the value out of it, and then do my computation. So try to always avoid sending box primitives, box types to C++, because there is no point in doing that. So the other point that I want to make is that try to avoid sending lists of box primitives to C++. Instead, just send a plain primitive array. So this is another important tip that you need to know if you are sending like working with primitives and using some C++ functions. Now obviously if you have an object, it's also better to send a list of objects instead of basically an array of objects instead of sending a list of objects. Because again, the reason here is that when we have a list of double, actually we can look at it. So let's go here. Let's comment this out. Test 2, test 3. So we have already seen in the previous lectures how to work with double arrays, primitive arrays, in when we send them from Java to C++. But what about a list of objects? Here, let's say a list of double primitives. So this gets a little bit complicated and it's better to avoid it. But for the sake of completeness, I'm going to show you. Public static void test 3. All right. So now in my basically array function, I have a list of double, right, for my AI. So in order to basically first I need to update the header file. So I select my Java file, array function.java, and run the Java H tool, and it updates the header file for me. And now the signature has changed to Java util list semicolon. So this is the parameter, and again there is no indication of what is the list, the type that this list holds, right? And that's because of Java erasure. So Java has the Java type erasure. So when you send a list of primitive double in C++, you lose all the information about what is the actual type that this list holds. So we have to deal with just J objects. We don't have J double or something. But again, let's comment this out and let's see what happens. So JNVM pointer, JClass is a calling class, array function, and JObject is now my list of xvals. List of xvals, right? List. So this is a list that holds the values x values, right? Or maybe let's rename it to x underscore list, which means this is x, but it's actually a list of double values, and it's just passed to C++ as an object. All right, and this J object is supposed to be list. So let's see what happens in Java. So if I create a list of double, let's call this x new, basically let's import the list from Java util, and here I'm going to create a array list, for example. And we don't need, we can just use a type diamond notation, and then x.add 1.1, x.add minus 1.1. All right, and then we are going, actually we should not return a double. Let's return a double array. Or maybe let's assume that this list only has one value, or we basically take the first value and return it. All right, that's one thing we can do, but maybe let's just try to go all the way and return the double array. Again, it's better to return a double array instead of list of doubles. It just makes the C++ code more complicated. Plus, you can do the type conversions directly in Java. So you come back to Java with a double array, and then you can quickly convert it to a list of double in Java if you need to. So here, and then so let's update the header file again. So Java Edge, run, update this header file, and now the return type is array double, right? The square bracket means an array, a primitive array of double values. So let's copy and paste it to our C++ code. JVM, JClass is array function, JObject is xList. So what do we need to do? So we have to think about how we actually get a value out of this list x. So if I say x.get at some index 0, what does this return? This returns a box value double. All right. and then I have to call the double value again on this to get the actual primitive type, double y. So this is what we need to, exactly what we need to implement in C++. We have to call the function get, the method get on the list object that we are sending on this X, and then it returns an object again. We have to call the double value on that object. So we probably need this for invoking the double value on the so here we need to use the find class Java lang double, and then we also need the method ID for this double value. But before that, we need to also do a J class list class, and then maybe let's use capital L, list class, and JVM basically find class, or I already have an instance of this object of this list, so I can use get object class. But for now, let's just directly use the class and find it on the class path, and it's in the Java util list. All right, and again, there is no information about the type of the objects that this list holds. It's completely gone. And then we need a J method ID to call the get function. So basically get ID, JVM get method ID. And again, this method get in the list class is an instance method. It's not static. So we pass a reference of J class to list class. The name is get. The signature is interesting. So what is the signature of this get method? Let's go back to our Java and let's click on this get. So this get, it's aware of what type of parameter is actually returning. So if I zoom in, so this basically what happens here is this: it invokes the Java util list, it invokes the get method on the list interface, and it takes an integer, which is the index, and returns a Java lang object. So it returns an object, but check cast, and it does a typecasting, Java lang double. So it does a typecasting as well. So if you go inside, you see it's E. So it typecasts to double again. So then the question is, what should we use as the signature of this? Is it double in this case, or is it a general object? So if I click on this and look at the bytecode again, yeah, the signature is in fact a Java object. It's not a Java double. And again, that's because of type erasure. So in the CPP, and so here basically it takes an integer and it returns an object, which is a Java /lang/ object, Java /lang/ object. So we don't put the double here because the signature of the method is in fact double. And the JVM does a typecasting check first, and then if it passes, then if the test passes, then it does an automatic typecasting. All right. So now what happens here? We need a J object, which is a XOBJ or value. The value that we want to get from this list is JVM call object method call so JVM. Remember, the get method takes an integer and gives us a J object, which is supposed to be double, right? It's an object and we can typecast it. So what do we need to do? We need to basically obviously we need to know how many elements are inside this list. So we actually need another method ID to invoke, and that's the size. So static J method ID size ID, and then we say JVM get method ID, and then here I'm going to pass a JList. The name is size, and the signature obviously is going to take no parameters and return an integer. Okay, and we can double check it. So if I go to the list interface and look at the outline, there should be a method called size, and if you look at the bytecode and zoom in, In the size, it takes no parameters and returns an integer. All right. So back to CPP. So I need to JInt length, let's call it len, is JVM call integer call int method, because I know that the return type is int. And I have to, so this is not a static, so this is instance method. So the object is xList and the method ID is size ID. And I leave the vararg alone, so the vararg parameters are empty because this method doesn't take any parameters. So this returns a list, and in order to prove it, I can printf it %d, and then I just pass len. So if I compile this in C++, this should work fine. We have a warning for this unused, which is fine, and then copy and paste to Java, and let's just try to do a sysout, or maybe let's just try invoke this method inside the array function .ai, and we pass a list of double. So this should print 2 because the size of this list is 2. Yes. If I add another number, x.add 3.1, this should print 3. Yes. All right. So now we successfully can get the length of the list, and then what I'm going to do, I'm going to create a JDouble array vals, all right, and of size len, the length, and then what I'm going to do, basically I'm going to write a for loop for int I equals 0, I less than len, I plus plus. What do I need to do? I need to get the double value out of each element of this list. So as you can see, it just gets complicated and complicated trying to send a list of these primitives to C++, whereas we could just simply send an primitive array and use one function of the JVM, which is get double array region, and automatically copy all the values because these are primitives. But again, for the sake of completeness, I'm showing you what to do here. So what do I need to do? I need to invoke basically, or call I need to call the get method, passing this integer on basically xList, which is a list. This returns returns an object, returns object. And again, I already know that the type of each object is going to be a double object, a double wrapper. And this double has a method called get double value, right? So I have to then call this. So yeah, we're just jumping through hoops, but this is how it's done. So we say JObject. Let's just create a JObject outside. JObject value obj. Let's say it's a null pointer, all right? And then remember, this JObject is a pointer, right? So we say this value obj is JVM, just call a object method, and we have to pass this xList. And what is the name of the method? The name of the method is get, right? So we pass the J method ID, the method ID of this get method. And the parameter list is integer, so we have to pass integer, which is I, right? And again, to prove, and this returns a JObject, and then we need to get the value. So let's create also a JDouble value. Let's set it to 0, and then value is basically I use the JVM. Now I call a double value, a primitive, call a double method, call a method that returns a double value. And now my object is value object, right? Because now this is this double value, this double object. The method ID is going to be double value ID, right? And it doesn't take any parameters and returns a primitive double. So to prove it, I'm just going to printf it. So value at index %d equals %f. So we have this integer index and value. I'm just trying to show to you that we're actually getting the values of that primitive type inside this list of wrappers, double wrappers. and we are going through actual hoops to do that. So it compiles fine. Let's copy and paste the dynamic library and invoke and run this test. Okay, so let's add some \n here and then \n here. So we also print the size. So size of list equals this, and then so let's compile again, copy and paste to the Java project, and then go back and run our as you can see, we are successfully retrieving the values inside this list of objects. The objects are wrappers, primitive boxes, primitive wrappers, and we are able to successfully unbox them. And as you can see, JVM doesn't help us with anything, so everything in C++ is manual. The only thing that JVM provides is that JVM says that I can give you access to all the methods. So you can invoke a size method on the list to get the list, and then invoke a method on get to get the objects, and then invoke a double method to return a double value, right? And that's all the JVM provides. So it doesn't do any basically typecasting. We have lost all the information about this what type of objects this list holds. But this is the general way we handle lists. All right, so we have to get the call the size and get methods first in C++, and then go through a for loop and get the J objects out of it, out of the list, and then maybe call a function of each object. Okay, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.